Hi there, and welcome to this lesson. In this lesson, we'll be learning solid shapes, solid shapes. And on the solid shapes, we'll be learning to find the surface areas of common solid shapes. So in the last lesson, we learned about volumes of common solid shapes, and this time around, we're going to be learning about surface areas. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, solid shapes, surface area of common solid shapes. Now, the surface area of a solid body or of a solid shape is the total area of the surface of the solid body. Okay, and what does this mean? Basically, we're starting with a cube. Okay, and I have this cube here, basically with all sides equal, obviously a cube. And the surface area of this cube is the sum of the areas of all six faces of this cube. Okay, basically the surface area of any body is the area that the surface of that body occupies, you could say, basically, but generally the area of the surface of the solid shape. So the surface of this cube is the six faces of the cube, and generally you'll be looking to find the area of the six faces of the cube, and basically you just find each area and add all of the areas up together. And for this cube, you have a cube. If you open up a cube, you'd have a net like this, a net that's made up of six equal squares. Okay, and basically the area of each of this square would be L squared. Okay, so because the length is L, the breadth is L, so you have L times L, L squared, and you multiply the area of each of the faces by 6. Okay, the area of one face by 6, and you have the total surface area of this cube. So basically the total surface area of a cube is 6L squared. Simple. Now let's talk about cuboids. So for cuboids is a bit more, it's quite interesting. It's pretty much the same principle, okay? But then we don't have equal sides. But we have length, breadth, and height. Now you're looking to add the areas of the front and back faces. Okay, so you have the face on the front, the face on the back, the face at the top, the face at the bottom, and the face on the two sides. Okay, and now each of the two sets that I just mentioned are equal. Okay, so the front equals the back, the area of the front equals the back, the area of the top equals the bottom, and the area of the two sides are equal. Now, the area of the front would be length times height. Okay, the area of the back would be length times height. The area of the top would be length times breadth. The area of the bottom would be length times breadth. And the area of the two sides would be breadth times height. Okay, and yeah, basically once you've done all of that, you just go ahead and add all of them up, and you should have that A equals 2LB, that's for the top and the bottom, plus 2LH, that's for 2LH would be for the front and the back, and then plus 2BH and for the two sides. And you can actually factorize that to simplify things out. You have that A equals 2LB plus LH plus BH. And yeah, that's it for cuboid. Now let's talk cylinders. Okay, things start to get interesting here. The cylinder. Now, to calculate the surface area of a cylinder, basically you have a circle at the top, a circle at the bottom, and you actually have a rectangle in the middle. It looks something like this. Okay, basically you have this rectangle. This rectangle is folded in. Okay, it's curved in to go around the circles. Okay, so you look closer at what we have here. So you have a circle at the top, a circle at the bottom, and then you have a rectangle in the middle, and you actually fold this rectangle in around the circumference of those two circles to form your cylinder. That's how you form a cylinder. Now, if you're looking to find the surface area of a cylinder, you need to find the area of the circle at the top, the area of the circle at the bottom, and then the area of that folded rectangle. Sometimes you could be asked to find the surface area of an open cylinder, and if the cylinder is an open cylinder, basically you have just the circle at the bottom. You do not have a circle at the top because the cylinder is an open cylinder. But in this case, we have a closed cylinder. Okay, and then for the area of the two circles, what you have is you have pi r squared times 2. Okay, because the radius of the circle is r, and you have pi r squared. as the area of that circle. And because you have two circles, you multiply that by 2. Now, for the rectangle, the breadth of this rectangle is the height of your cylinder. Okay, do you agree with me? The breadth of this rectangle is the height of the cylinder, and the length of this rectangle actually goes around the circumference of the circle. So the length of this rectangle is the circumference of your circle, and basically you have that the length of this rectangle is 2 pi r. So you have length as 2 pi r and breadth as h, and I tell you that the area of this rectangle, the rectangle that you fold in, is 2 pi r h. And if you're looking to find this total surface area of the cylinder, basically you add the area of the circle at the top plus the area of the circle at the bottom plus the area of the folded rectangle. You have 2 pi r squared plus 2 pi r h. And you can factorize that to make things simpler. You have 2 pi r plus h. Make sense? Let's move on. Okay, now let's talk about cones. Now, cones are actually very interesting. Okay, the way we form cones, very interesting. Why? Because we form a cone using we'll form cones using a sector of a circle, okay, and then a circle. Okay, so this the shape that goes around your circle is not a triangle but a sector instead. So you have a sector, and what you actually have at the bottom is an arc, and then the radius of that sector is the slant height of your cone. Okay, now if you recall, when we're working for the volume of a cone, we make use of the height, the vertical height. And when you're doing surface area of a cone, you make use of the slant height. And if you're ever given the vertical height and radius, if you look at that cone there, you can see that the vertical height, the radius, and the slant height form a right angle triangle. So you just go ahead and apply Pythagoras' theorem. So h squared plus r squared would equal L squared. Or if you're given the slant height, for example, when you're asked to solve for volume, you need the vertical height to solve for volume. You don't use slant height to solve for volume. So you subtract the square of the radius from the square of the slant height, and it should give you the square of the basically just your basic Pythagoras theorem. And then let's talk now about our net there. We have a sector of a circle with an angle theta. We don't use theta, but theta is there now. Okay, obviously it's a sector of a circle. There is an angle at play. And then we have a circle at the bottom. Now, the area of this sector is theta over 360 times pi L squared. Okay, because L is the radius of our sector, basically in the circle. So you have theta over 360 times pi L squared. But when you ask to solve this question, you're never given this angle. Okay, you're hardly ever given this angle because you don't know what the angle is. Basically, the parameters you usually asked to work with: the slant height of the cone, the vertical height of the circle of the cone, and the radius of the circle below. So we're going to try to establish an expression for this theta over 360. But like I said, you're hardly ever given this theta over 360. And here's what we're going to do. Now, if you look at the arc, you look at that sector and you look at that arc, okay, and you consider the length of that arc, you'd find that the length of that arc equals the circumference of the circle of the base circle of the cone. Basically, if you look closely, look at the sector, okay, t with theta and L, the length of the arc in that sector, it basically goes around that circle. So the length of that arc equals the circumference of that circle. And if you remember, the length of an arc in the circle basically is theta over 360 times 2 pi r, or basically 2 pi L in this case, because L is the radius of that sector. Okay, but then we've established that that equals the circumference of that circle. Circumference of the circle radius r, and circumference of that circle is 2 pi r. So the length of the arc of the sector equals the circumference of the circle. And now what we have here is a relationship, okay, a very interesting relationship, and we're going to use this to find out exactly what theta over 360 is. Because theta over 360 times 2 pi L equals 2 pi r. What we're going to do is we're just going to make theta over 360 subject to formula. Basically, we can cancel out 2 pi's from both sides and then divide both sides by L. What we have in the end is we have that theta over 360 equals r over L. Okay, so now what we have is something we can use to replace theta over 3, because like I said, you're often not giving theta, the angle of the sector. Basically, you ask to solve for a cone, so usually just giving the radius, the height, the slant height. But now we've established that the angle over 360 equals the radius over length. So basically, we can go ahead and say that the area of a sector, replacing theta over 360 with r over L, equals r over L times pi L squared. Okay, and then L would cancel one of those L, and what you have at the end is that the area of this sector is pi r L, where L is the slant height of the cone and r is the radius of the circle below. Okay, so we have the area of that sector, and then the area of the circle, quite simply, is pi r squared. Okay, so pi r squared is the area of that circle. And when you add both of them together, what you have is you have pi r squared plus pi rl. And if you factorize using pi r, you have pi r plus l. And that is the total surface area of a cone. Okay, so we've talked about cubes, cuboids, cylinders, and cones. Basically, when you're doing pyramids, pyramids follow the same principle okay, basically you apply some of cuboids, you apply some of the cone. But basically, if you're looking to find the surface area of a pyramid, you just need to find the surface area. If it's a triangular pyramid, so the area of the triangle at the base, okay, and then the area of the triangle, the upstanding triangle. And one thing you need to know when you're solving for the area of the vertical triangles, let's call them that, the upright triangles, is you make use of their slant height, not their vertical height, for each of the triangles, because each of the triangles is bending. If you can remember what a pyramid looks like. Okay, so you don't make use of the vertical height, you make use of their slant height. So you use the slant height to find the area of each of those triangles, and then you just add all your areas up together. But then finally, let's talk about spheres. And spheres is just a formula you have to remember at this time. We're not going to tell you exactly how this formula comes about. So just remember that the surface area of a sphere is 4 pi r squared. And that's it. Okay, that's all the firepower you need to solve the surface areas of common solid shapes. Okay, so you can go ahead now and attempt questions on the worksheet. Bye for now.